Welcome to Delzy Scholars YouTube channel. In today's class, we want to briefly look at alkanoates. This is JAMB syllabus under alkanoates, right, under organic chemistry. So we're looking forward to see if we can finish this in the next 5 to 10 minutes. And of course, we move forward. Now, first, what is alkanoates? Alkanoates is an ester, right? They have a general formula of RCOOR, which can be written as RC. Now, this is esters, right? Now, how do we name them? They are named as alkyl alkanoates. Now this part is the alkyl, and this part is the alkanoate. So if I have an example, I have something like this: CH3, COO, CH3. Now this is methyl, and this is ethanoate, right? So this methyl, why do we call this guy ethanoate? Because it contains 2 carbon, 1 and 2. 2 carbon alkane is ethane, right? So this is going to be methyl ethanoate. What if I have something like this? I have H. Now this is ethyl, because this ethyl, this part, the right hand side is the ethyl, it contains 2 carbon, and the left hand side is the alkanoate, it contains 1 carbon. So this part would be ethyl methanoate. Alright? Now, so this is how we name esters. Now, let's move down to the preparations of esters. Now, preparation. Esters are prepared in a process known as esterification. Now, this in esterification reaction, a carboxylic acid reacts with an alcohol reversibly in the presence of an acid. So what actually took place here is that the R of this alcohol replaces this H, and this H goes in here. Alright, so basically the R from the alcohol, the alkyl group from the alcohol, replaces the H from this acid. So this becomes RCOOR. This replaces this guy. We now have plus water. Now this H comes out and pick up OH, is going to form water. So this is our ester. So in exams, if you're being asked, the process of producing esters is known as esterification reaction. Okay, so let's take an example to see how this will look like. Let's say we have ethanoic acid. We have methanol. Now, I do not care. Whatever they like, they should add here. Everything apart from the OH, I'll take it and replace the H. The OH is what is meant to be constant, because this OH is going to pick up this H from here and form water. So here becomes, this come here, and this come here. So we have CH3, now if you want to name this, the right hand side is 1 carbon alkyl, so this is methyl. The left hand side is 2 carbon alkanoate, so this becomes, so that is how we can prepare ester. The process of ester production or preparation is known as esterification reaction. Okay. Now, the next one says fat and oil fat and oil as esters. Now, class, look up. Now, esters basically is of two forms. We have the oil and we have the fat. The oil is from plant origin, while the fat is from animal origin, right? So both fat and oil could be actually called esters. They are triglyceride, right? Triacyl glycerol or triglyceride. Now, basically, when esters is in a solid form, we call it fat. When esters is in a liquid form at room temperature, we call it oil. So it's important for us to know that fat and oil are esters. Esters, I'll say fat and oil are esters of glycerol and fatty acids. All right. So in case you're being asked, is fat, oil esters? Yes, there are esters. Now, saponification. Now, saponification is a process of soap production. So I'll say this is saponification is alkaline hydrolysis of esters, that's fat or oil. But most of the times they might not use this definition. They could say the process of boiling fat in aqueous alkali is dash. Now look at this. Now the process of boiling fat in aqueous alkali is dash. Please, the answer is still saponification. Now, soap is actually produced via this process. So saponification is basically the process for the production of soap. All right. So how do we achieve that? We're going to use a fat and of course use an alkali. The alkali can either be sodium hydroxide or potassium hydroxide. If I use sodium hydroxide, the soap that will be formed will be a hard soap. Whereas if I use potassium hydroxide, the soap that will be formed will be a soft soap. So saponification is basically the process of soap production, which can be defined in either of these two ways. It's either it is defined as the alkaline hydrolysis of esters or the process of boiling fats in aqueous alkali. So take note of these two definitions. All right. So let's talk about soap. We've talked about soap. All right. So soap is actually alkaline hydrolysis of fats. All right. So when you actually carry out alkaline hydrolysis means, now this is alkali means in a basic medium. Adding aqueous alkali to fats and boiling it results to soap. When you boil it, you allow it to cool. When it cools, it forms a bar soap. Now what is margarine? Margarine is hydrogenation of oil. Please take note of these two. Soap is produced via alkaline hydrolysis of fat, right? Now margarine is a solid that is produced from oil, right? So when you hydrogenate oil, the oil that will be hydrogenated are unsaturated. So when you hydrogenate unsaturated oil, you're going to form a solid that is fat, and that fat is what we call the margarine. So what you use in eating your bread, right, is basically gotten via this process. They bring oil that contains a double bond and of course add hydrogen in a process known as hydrogenation. Once this process is completed, the oil changes from oil and becomes a solid. Right, so that is how we got this. Now we have the last guy, soap and detergent. Obviously, we both know that these two guys are used for cleansing purposes, but we need to be able to differentiate between two of them. The first thing, we'll need to know their origin. right? Effects on hard water. Biodegradability and compound. Now, when we talk about soap, the origin of soap is from animal. That is fat, right? So fat is of animal origin, I told us earlier. Detergent is gotten from petrochemicals. Now, this forms a scum in water. Soap forms scum in water. Why? So, what is the effect of hard water on soap? Soap has no effect on hard water. Instead, it's going to form a scum, whereas detergent has effects on hard water. No matter how hard a water is, detergent will still be best for that. It does not form a scum. Now, biodegradability, yes, it is biodegradable. This is not biodegradable. Now, example is sodium stearate. And this is sodium lauryl sulfate. So I believe you've learned something today, right? This is basically 95% of everything you need under ALKANOATES. So I believe you've learned something. If you have learned something, do not forget to hit the subscribe button and check for the next video.